So don't nobody actually watches your lessons?
I don't know if they do or not.
It's being incognito.
So there's our product rule along with our quotient rule. We're going to start by evaluating with these. Use the properties of logarithms to evaluate log base 4 of 16x raised to the third power when that x is going to be 256. So it's going to be another properties day. And yes, we are evaluating. So essentially what we're doing is taking the value and plugging it in for the variable. Before we do that, let's use our properties so that we can, simplify this thing a little bit so we can actually plug it into our calculators. What would be step number 1 here? Yeah, let's bring the 3 down in front so we can multiply by it. And now what do you suppose we want to do? We want to, we could do that. Let's go ahead and separate these out though. 3 times the log base 4 of 16 plus the log base 4 of x. And at this point I'm going to combine a couple of steps. Can't plug this into our calculator unless we have the Casio, so we actually want to do the change base formula here. So let's back up. Change of base formula states that the log base 4 of 16 is equivalent to log of 16 divided by the log of 4. And now I'm going to go ahead and plug in that 256 for x and then divide by log of 4. So now we all can plug this into our calculators. Log base, or log 16 divided by the log of 4. What do we get? 2. Log of 256 divided by log of 4. Four. 2 and 4 will get us at 6. 3 times 6 will get us 18. So if anything else with today's lesson, didn't seem like it was anything new. It's just hopefully we're getting more comfortable with using these properties, exponent, product, as well as sum or difference. Let's go ahead and do this again. So there's our log. X value that we're going to evaluate for is 1,000. And this time I want you to walk me through my steps. So what do we do next? Move the 2 down below, right? Okay, then what? Separate them out. We most certainly could. That's what we did in the last one. Has anybody asked the question yet? Well, why didn't we just plug it in there? Can we take our 1,000 times 10? Yeah, you most certainly could. But Jaden said we better go this route. So. It's good use of our properties, so that's why I'm glad we went this route. But yeah, now we can plug it in again. And let's go ahead and plug in 1,000 for x. So log of 1,000, log of 100. Calculator time. Log of 10 over log of 100. Anyone? Log of 1,000 divided by log of 100. 1.5. Add them together, multiply by 2. I want to go back a few steps because, let's see here. What did I want to do? I think it was at this step. We could have went a different route if we wanted to. You know, instead of splitting them up, we could have went to our change of base formula right away. We could have went 2 times the log of 10x divided by the log of 100. And then you could have used your addition rule. And I'll go ahead and plug it in there right away. And now what's the log of 10? Let's plug that into our calculator real quick. One. What's the log of 1,000? 3. Log of 100?
2.
Whoops. 4 over 2 is 2. So that's another way you could have came up with it if you decided to go to that route. Number of different ways that you can simplify these logarithms. Last one. We are no longer evaluating, but now I want to solve. On Friday, we dealt with the problem where we had y was equal to 2 raised to the x. And we determined for that bonus question that y value was like, what was it, 1.25 times 10 raised to the 11th. That's how many pieces of paper that we had. So we wanted to know just how many folds it would take to reach the width of the earth. So what did we do to solve this thing? Yeah, we had to incorporate logs, right? Okay. Had to incorporate log form. So you can do this. This is where we actually want to introduce the logs. You can do, let's do it this way. Let's start by, we have 1,000 raised to the 9x is equal to 100. And the first thing we could do is convert it to log form, which would mean if I take the log base 1,000 of 100 now, that is equal to our 9x. And if we continue to solve this thing, change of base formula is what we want to use here. And if we want to get rid of that 9 on the right, we could divide both sides by, let's not divide, but instead let's multiply by 1/9. That way we know that's where it's going to go when we plug this thing in. Answer that we're coming up with. You're going to get the decimal, but if you hit your fraction button, it's actually 2 over 27 is what you should be coming up with. Be careful when you plug this in. this needs to be in parentheses. The 9 times the log of 1,000. If you don't put it in parentheses, it's just going to view it as log of 100 over 9. But again, you should come up with 2 over 27. And once again, I'd just like to take a moment to show you another way how to solve this thing. We are once again going to use logs, but now we're going to, instead of converting it to log form right away, let's do this. 3 is equal to 3, right? And we were told from day one that we could multiply both sides of the equal sign by any value we wanted to, and it would remain equal. So what if I give you 3 is equal to 3, and then I decide to say, alright, can I just take the log of both sides then? Would that remain true? Yes. Okay. This property here works with logs as well. So what I'm going to do in this step is I'm actually going to take the log of both sides. And now we can evaluate it this way. What do we do with our power? Bring it down. And then we're just multiplying here between all 3 of these, so we end up dividing both sides by this. So x is again equal to log 100 over 9 log 1,000. And again, there it is. This is actually the way that I used to teach it, right here. Just take the log of both sides. Questions? It's kind of a review lesson, just using those properties again.